Bismillahirrahmanirrahim. Today, inshallah, I shall talk about solid geometric figures. These are some examples of solid geometric figures. The geometry that we have been doing so far was with plane figures. The triangles, the rectangles, the squares, and the circles, these are called plane figures. Compared to what you see before you here, these are called solid or three-dimensional geometric figures. Some examples, as you can see, include the cylinder, the cone, the cube, the sphere, the pyramid, the prism, the tetrahedron, and the octahedron. Now, solid figures can be divided into two broad categories. They can be classified either as polyhedrons and non-polyhedrons. As you can see, being a polyhedron must be something special because everybody else is called a non-polyhedron. So, you might say, okay, what is a polyhedron? Well, a polyhedron is a solid figure, a three-dimensional figure that is bounded only by polygons. That is, all the sides are polygons. These are some examples. As you can see here, all of these figures, their sides are all some kind of polygons, whether it be a rectangle, a triangle, or a pentagon, or a hexagon, etc. So these are examples of polyhedrons. Some examples of non-polyhedrons are the following. Here's a cone, a sphere, and of course a cylinder. Now, if you look at a polyhedron, there's some terms that we need to know. The corners are called vertices, singular being a vertex. And then of course there are the edges, and then each side is called a face. So a polyhedron has vertices, edges, and faces. Of course, the definition of a polyhedron is that all the faces are polygons. Now, polygons, if you recall, are geometric figures whose sides are all segments. Here's another example of a polyhedron with the faces and the vertices and the edges. Now, if you recall, polygons are named after the number of sides that they have. So we had a triangle, a square, a rectangle, and then you had a pentagon, hexagon, heptagon, and a nonagon, etc. So polygons were named after the number of sides they had. Now, polyhedrons are named after the number of faces they have. So a tetrahedron has 4 faces. A cube's technical name, since it has 6 sides, is a hexahedron because it's a 6-sided polyhedron. An octahedron will have 8 faces. A dodecahedron will have 12 faces, and a icosahedron will have 20 faces. Now, these 5 polyhedrons that you see before you are no ordinary polyhedrons. These, in fact, are known as the Platonic solids. Platonic solids are unique. There are only 5 of these types of solid figures in geometry, period. They are considered to be the perfection of polyhedrons, so to speak. Now, their faces are all equilateral polygons. Not only are all the faces regular polygons, each vertex appears the same. In other words, they're symmetrical from all sides. If you look at this particular edge, for example, over here, you'll see that there are 3 pentagons on this side. If you look at this vertex over here, you'll see again that there are 3 pentagons over here. Now, over here, in this figure over here, the octahedron, if you look at this vertex, you will see that there are 1, 2, 3, 4 triangles surrounding. And that will be the case at every vertex. You cannot make any Platonic solids with any other geometric figure. On the other hand, the type of polyhedrons that you can make is only limited really by your imagination. Now, going back, solid figures, again, if you recall, are divided into 2 broad categories. The polyhedrons, these are solid figures that are bounded on all sides by polygons, and the non-polyhedrons that are otherwise. Polyhedrons can also be classified in a second way. Among the polyhedrons, there are 2 of interest for us, and these are the prisms and the pyramids. In this chapter, you'll see we'll study a lot about prisms, and we shall study a lot about pyramids. Now, the difference between prisms and pyramids is that prisms have 2 bases and pyramids have 1 base. Most everybody is familiar with the architecture of a pyramid. Now, a prism, on the other hand, has 2 bases. In other words, it has 2 faces that are the same. In the figure on the left, you see that there are 2 hexagons. Now, these are the bases. The other faces, 1 for each side of the hexagon, they form the lateral faces. So prisms have 2 bases, whereas pyramids have 1 base. And the sides of the prisms are called the lateral faces. Prisms are named after their bases. So over here, you see that there's a triangle as a base, and then there's a second triangle over here at the other base. So this would be classified as a triangular prism. Now this is a rectangular prism because here's a base over here, and then there's a second base over here. Now this is a pentagonal prism because the bases are pentagons. And this would be, of course, a hexagonal prism because the bases are hexagons. Now you notice that all the sides are rectangles. These are called the lateral faces of these prisms. Pyramids are also classified based on their base. So if the base is a rectangle, the pyramid is classified as a rectangular pyramid. And if the base is a hexagon, the pyramid is called a hexagonal pyramid. And if the base is a triangle, which is not shown over here, it would be called a triangular pyramid. So here's a review. First figure is a cube. The second figure is a prism. Now the green figure here is a triangular prism because, as you can see, the bases here are triangles. And this is a triangular base pyramid or a triangular pyramid because the base here is a triangle. Now this is a pyramid and the base is a square. So this is a square pyramid. This, of course, is a cone, which is not a polyhedron. And this is cylinder, which is also not a polyhedron. A sphere, by far, is the ultimate anti-polyhedron, or, of course, it's not a polyhedron. Now, slanted prisms are called oblique prisms. Now, straight prisms are called right prisms. The height of the prism or the altitude of the prism, if it's a right prism, will just be one of the edges over here. But if it's an oblique prism or slanted prism, the height of the prism is the vertical height like this. You have to drop a perpendicular line over there to the base over here, and that in fact would be the height or the altitude of this prism. So there are two types of prisms, the right prisms and the oblique prisms. Here's another example. This is an oblique triangular prism. It is a triangular prism that is oblique. Now, just like prisms can be oblique, you can have pyramids that are oblique. They're called oblique pyramids. Imagine this cube was like a box. If you open the box and lay it flat like this, that's called a net diagram, or the net of this figure, or the net of a cube. So if the polyhedrons were like made of boxes type material, and if you would open up those polyhedrons, you would get what's called a net diagram. Here are some more examples. If you open up a square-based pyramid, for example, you would get like a star shaped over here like this. It takes a bit of imagination to try to fold these and try to figure out what kind of a polyhedral figure this was. I won't spoil this for you. You can try this on your own. Now I'd like to finish off today by talking about figures that are less commonly known. Now what you see before you here is a frustum. A frustum is kind of like a truncated cone. In other words, if you take a cone and slice off the top part of it, what's left over is a frustum. You can have a frustum of a cone, or you can have a frustum of a pyramid. That is, if you chop off the top of the pyramid, what's left over is a frustum, kind of frustrated pyramid, or a frustrated cone. Finally, this beautiful figure, the donut figure, is given a name. It's called a torus. There's beautiful mathematics associated with this figure, and I thought we would end with this. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.